morning, everyone. So we are starting with our session, CTO Conclave, Decoding the Success of 5G's Grand Debut, Part A. So today we have with us Mr. Magnus Everbring, Apex CTO, Ericsson. Then we have Mr. Mike Fitton, VP and GM, Network Business Division, Programmable Solutions Group, Intel Corporation. Then we have Mr. Azhar Saeed, Global CTO, Telecom, Red Hat. Then we have Mr. Jayanta De, Executive President, 5G Business, HFCL. Next we have with us Mr. Ryan Tonelli, Chief Operating Officer, DriveNets. Then we have with us Dr. Badri Gumatham, Group CTO, STL. Then we have with us Mr. Harpinder Mitharu, Business Head of Product Marketing and Wired and Wireless Business, AMD. Then we have with us Mr. Girish Bhatia, Director, Sales Engineering, Sienna. And then we have our moderator, Mr. Nitin Shah, partner with KPMG. Sir, over to you.
Okay. Good morning, everyone. Am I audible? Well, great. Thank you. So I know it's a Sunday morning, considering the match we have in the evening. So I think it's difficult for all of us to attend this session. But I think thank you very much for everyone who is attending this session. And we will have a really interesting, impactful, and insightful session considering the esteemed panelists that we have today. Decoding the success of 5G's grand debut. I think it's a very interesting topic that the organizers have taken. Right. So just a year back, we have this eventful launch of 5G services in India, inaugurated by Prime Minister Modi in the same IMC 2022. And we all are very excited about the event. We all consider this as quite an event in the communication services or in telecom industry in India. But why is it so eventful? Why we all consider this as a milestone? We have been upgrading on telecom technologies for years. So we had 2G to 3G, 3G to 4G, and now it's 5G. So why is it so different that we consider 5G as a milestone event? I think the way I take it, I believe that while all these technology upgrades have provided or enhanced the service levels for the services provided to the end users, I think broadly the use cases were revolving around the user landscape across those services. 5G is giving us an opportunity to put up use cases across the business as well as community landscape. So that's where I think it's differentiate and why I think there's so much of excitement when we talk about 5G. 5G has opened a plethora of opportunities, driving digital enterprises, digital economy, as well as opening up opportunities for a new business and operating model supporting the entire startup ecosystem. 5G is also supporting some of the flagship programs of Government of India. When you talk about Digital India, when you talk about Startup India, Atmanirbhar Bharat, and many more. As one of the estimates, 5G is supposed to accelerate the economic growth of the country, where 5G itself is going to contribute to roughly around 2% of India's GDP over the next few years. So that's a grand promise, and that's where I was excited when I looked at 5G's grand debut. I think this is really grand if there's a expectation to contribute to 2% of the GDP. But the other important aspect of the success for 5G, in my view, and I think that I'll also talk to my fellow panelists here, the technology is best when it brings people together. And that is the mantra I believe 5G is adopting. So the three key levers for the growth that 5G is committing is promising the industry collaboration and convergence. Right? So that's one of the levers that 5G is driving. The second is boosting the socio-economic growth by bringing the rural and the urban population together. And third, of course, the enhanced customer experience that it basically promises. So over the last 1 year, I think the pace at which we have deployed 5G technologies and services in India is commendable. With more than 3,000 or 300,000 sites, 5G sites, covering 700 plus districts, India has become nearly the second largest 5G infrastructure globally. The pace at which we are deploying 5G services and supported by some of the emerging technologies, when we talk about generative AI, when we talk about industrial IoT, when we talk about edge computing, I think it's basically driving the digital transformation for the country, which is taking us towards our next ambition to be the third largest global economy by 2030. So that's the promise that 5G is making to all of us. While there are a lot of promises on 5G, I come with a cybersecurity background, so I can't be not talking about cybersecurity. I do believe that it is also to a certain extent providing some unique challenges when it comes to cybersecurity. When we talk about all the other technologies, as I said, the use cases were largely around the user landscape. I think some of the use cases with 5G is promising, be it enhanced mobile broadband, be it URLLC services, when you talk about machine-to-machine communication. I think the risk and the threat landscape from cybersecurity is very, very different. And hence that needs to be considered with a very different perspective altogether. The second aspect is the regulatory compliance. The recent that we all heard about the Data Privacy Act, the DPDPA Act, which has come in country, is also impacting. And when I say impact, I'm very cautious. Impact both from positive as well as negative side. But there is an impact on some of the use cases of 5G when we talk about compliance to some of these acts. So with that, let me move to my esteemed panelists. And there are four key aspects which we will try to cover, and will be open to take input from the audience as well if there are specific areas that you want us to discuss further, with permission of my panelists. What is the potential of some of the leading use cases that we have seen globally, be it cloud computing, be it FWA, be it communication platform as a service, and many others. So what are those use cases which would be more prevailing in India? Impact of emerging technologies such as generative AI, and when I say impact, I think impact on both the sides. One is on the adoption of 5G as a services and how effectively we can operate or efficiently we can operate 5G services by leveraging some of those technologies, and also how we can enhance our 5G services using generative AI. So that's the second aspect. How is 5G is driving the digital transformation, boosting the Indian economy? And I think we have some sense over the last 1 year how it's helping out, so I think there's a merit in discussing that. And third, certainly there's a role that regulators need to play to basically assess how we can have an effective deployment of 5G, effective consumption of 5G services, and how should we get the industry collaboration further for the users of 5G. So with that, I will turn towards my colleague Ryan. Ryan has a fantastic experience in managing the large deployment of infrastructure. So what are some of the challenges, Ryan, that you see when you're looking at such a large critical infrastructure deployed at such a large scale and with such a fast pace? So what are those challenges that you can help and share with us?
Yeah, great question. Thank you for that. So first of all, thank you for having me. And secondly, I think we could probably have a panel just about this one topic itself. So I'll try and cover this at a pretty high level, but if any of you want to find me after the session, I'm happy to talk about it in more detail. I think there's a couple of assumptions we have to make before we dive into this. One of them is that 5G is going to drive an increase in the number of physical devices on the network. And by that, I don't just mean handsets. I mean physical IP-consuming devices that are sitting behind hotspots and FWA CPE. And I think we also have to assume that generally over time, the bandwidth consumption profile of all these devices is going to go up, right? So if we assume all these things are true, then I think there's three key areas we have to think about. The first one is edge computing. And I know we talk about edge computing all the time, and it's this, sort of amorphous concept that is different on an industry by industry basis. But let me give you an example of a place where I think this has a meaningful impact in the 5G world. So let's say that you as an operator want to go train an AI, right? And you want to use, anonymized, tokenized data from your user base to be able to do that. Moving that data around, especially to a data center where you've got your training farm, has an implicit cost in your infrastructure, right? So being able to anonymize and tokenize and summarize that data closer to the edge has meaningful benefits in, the TTL of your, let's say, your backhaul and connectivity infrastructure. So that's one piece of it. The second is capacity, right? And this is one that has so many dimensions. It's almost incomprehensible. The first one is, if you're going to do edge computing, where do you put the compute and how much can you put there, right? Some of these cell sites, if that's where you're putting it, you may not have a ton of space and power to be able to accommodate growth. So understanding what your strategy is, when you're capacity constrained, what actions do you take? Do you deploy and then undeploy services based on what's relatively available? Thinking through your responses to those kinds of constraint scenarios, I think, is really critical before you dive into that end of the pool. The other is the physical network capacity itself, right? I could talk about RAN capacity. Actually, I couldn't because I'm not really a radio guy. I'm sure everyone else in this room could probably talk about RAN capacity planning better than I could. But then there's the backhaul piece, right? But we have to think more longitudinally about capacity. Don't just think about backhaul and RAN. Think about your edge, your aggregation layer. Think about your core. Think about your N and I edge, right, with all your peering and transit partners. 5G has the capability to more rapidly and more severely impact your overall capacity utilization profile more quickly than previous technologies, right? So being able to quickly respond to capacity demands in all those dimensions of your network are really, really, really important, right? How quickly can you add capacity with a peer? Do you know the answer to that question, right? You probably should, right? And if you've got hundreds of peers, being able to address each one of those needs independently is pretty critical. And then the last is the operations and maintenance piece of this. So, you assume you get this network deployed. It's large and complicated and has a ton of utilization on it, and you have to go do work. You have to add capacity or do upgrades or change devices. Your goal should be to, decrease the scope of the widget you need to touch to the smallest possible piece, right? Like, if you can disaggregate your hardware and your software, that means that you can touch those two pieces of your infrastructure independently. Without having to interact with a single supply chain, you can interact with 2 or 3 or 4 or 5. And then if you think about the compute side of things, a microservices approach, I think, is pretty critical, right? The thought of having to reimage a server every time you want to go deploy a new service in your edge computing infrastructure is sort of crazy, right? What you want to do is destroy a container and recreate it. So being able to address those compute needs in a microservices way, I think, is critical. And then last is be open. Locking yourself into proprietary technology just means that you're locking yourself into fewer options with regard to software and supply chain and all these different things that are relatively open and mature today, right? So use those technologies where they make sense for you, and I think you'll end up with a much more scalable and smooth deployment experience over time. Thank you.
Great, thanks, Ben. So before I move, I think I just wanted to cover another aspect. When you talk about data and you talk about data normalization, I think one of the other important aspect which is coming when you talk about the data is there's the amount of data that you capture, which is fine. You're looking for taking the services, you have to provide certain information, and that's the data. And I'm primarily focusing on the personal data. But there's a huge amount of data which is getting generated, right? And that obviously is the new oil that we talk about, the data which is generated. And there's the amount of data which is getting inferred as well. So how do you manage that? And it obviously depends on the complexity of the use cases. But that's another important aspect, and which again impacting the deployment of 5G, or more not as a technology, as a service, when you're talking about the use cases and keeping the cybersecurity aspect around that. So we'll cover that, but that's a very important aspect. Next, if I move to Magnus Ju, and I think from Ericsson, and Ericsson has been part of the India digital journey, and I'll be very honest, when I was preparing for this session, I realized that Ericsson is part of the telecom journey in India for almost over 120 years, with the first switch getting deployed in 1903. So that's fantastic, and you have seen the journey of India on the communication services platform, driving the economic growth that the sector has always supported. So how do you see India's journey on 5G and how it can further enhance its growth on 5G? I think, as I said, there's a lot of buzz around 5G, but how are we taking it up, and how are we going to support the Indian economic growth as well as the industrial growth?
Thank you, and good morning, everyone. So first, I'd like to express my sincere admiration. What has happened here in India over the last year since the previous Mobile World Congress is absolutely fantastic. Almost 340,000 base stations, on the ground and operational. That is a stunning achievement. There are many things that can go wrong when you make a large deployment, right? But I think the operators here have really been showing great dedication and ensuring all major cities are covered. A number of factors come in place. I think regulation is one of them also. The spectrum auctions we had last year gave clarity, and then the improvements being done in right-of-way, etc. Now we have a fantastic base of 5G, and we're taking the next steps. And here's, of course, to leverage what's on there and to excel further. If you take a regulation, there more can be done. I'd be happy to see emissions being looked over, how much output power you can have at sites, which will drive performance if adjustments are done, as an example. But also, on the network side, this is a great first step, but more steps to come. 5G will live and thrive for a very, very long time, and it will evolve. If you look at what we have in terms of functionality, there are key important steps to take in the next years to come. 5G standalone, slicing, carrier aggregation, red cap, exposure, etc., are things that should be implemented in the network to be the base for the monetization that's now starting. And that will drive opportunities in new areas such as enterprise, industries, and the public sector. Everything will be connected. And it will be connected through differentiated services. This is a key thing here where regulation has to support the business opportunity for the good of consumers and the good of enterprises. So I think in the next years to come here, making sure that applications can leverage on the abilities in the 5G network with first-class performance. Just as a side comment, when I look at speed tests, typical speeds in major cities have jumped 15 to 20 times 4G with 5G compared to 4G. That opens up opportunities, right? So the performance has to be there, differentiation has to be there, and then being able to expose the values in the networks to app providers. That will unleash innovation. What we saw here at the inauguration with 100 test systems being open at universities is a fantastic base for future innovation. Take that opportunity and lead how industries can digitalize and be cutting the wires and then improve quality performance with 5G. Next few years is a fantastic opportunity.
So when you talk about innovations, do you also see that if we really want to explore the growth that 5G provides, there is a need to innovate more business and operating models? I was just reading, and I think communication platform as a service is one such model, because then you can provide this as a service to maybe the startup ecosystem to innovate some of the newer services. So are we seeing this kind of a growth? Magnus, as your role obviously globally is, are there such kind of a scenarios you believe are being leveraged across geographies? And do you see this as a potential in India? Yeah.
So, I mean, the question was on indoor and other deployment.
So the question is more to basically understand possibility or need for innovating business models to leverage 5G.
Yeah. Oh, thank you. So I think on the business aspects here, one thing is technology, right? The second one is how do you put it place in the marketplace? How do you make it work? And here we have to innovate a lot more, we being the industry. I said before, differentiated services. Network slicing is a key functional support in the network. That we're now having our hands on, how to configure the networks, etc. The challenge now becomes, how do we price it in the market? What's the value to consumer? What's the value to an enterprise? And this space needs to be crafted out now. Early movers will have an advantage. So I think India, again, is perfectly set here. Another area then is the exposure. And we just did a launch with Deutsche Telekom a month ago, where they're starting their first exposures and leveraging that on their enterprise portal. One example, applications can now ask through the aggregator platform, their enterprise portal powered by Vonage, they can ask the network, in which country is this device? Okay, so it's a very coarse level. But that is good information for credit card companies. Me being living in Singapore, if my credit card tries to make a transaction in Delhi and the app gets the answer that my device is in India, they have a higher correlation and they're more likely to grant that transaction. That information has not been tradable before for the mobile operators. Now it is.
Thank you. Thank you for this. So with that, if I move to you, Girish, and I think it's a logical movement to see what are the real benefits of 5G capabilities that the industry can leverage on, and specifically from the India perspective. There are a lot of promises which we see that 5G is going to bring the financial inclusion, social inclusion. So how do we leverage on some of those benefits that we see or capabilities that we see 5G is providing?
Thanks. Good morning. So if I go back to the inclusion piece, if you look at India market, it's split into two portions, the urban and rural divide. If you look at urban, we have more than 100% penetration of mobility of wireless internet. But that's not the case in the rural areas. We are still at 40%. And 5G brings a very good opportunity to actually, bridge this divide. Earlier challenges of infra that we still have still exist. And I know government is working on a broadband project. But if you look at 5G, especially the FWA case, this will really help in bringing a divide much, much smaller because it will be easier to roll out networks based on FWA because FWA has kind of two streams that I see. It's B2C and B2B. Now the B2C piece is where we will be able to kind of bridge the rural divide and bring more opportunities of farming, of education, of all other entrepreneurship that the Modi ji wants to do. So this is a very, very big opportunity for us to kind of bridge that divide. Now, when you come to B2B, FWA is nothing but it's going to offer a lot of bandwidth. We heard from all the esteemed panelists, stacks of compute, stack of application. They're going to be there at a particular layer in the network. What we actually need to make this work is connectivity and connectivity with enhanced capacity. So that's going to change a lot. And this is going to change the way networks are built actually. So in India, we use innovation to actually add more capacity, add more simplicity, add more services, but at a better cost than what we were doing earlier. So that's going to change because the way the services move in the network, that's going to change. And you will see a lot of innovations in optics, performance optimized optics, space optimized optics. They will come very close to the user. As Ryan was mentioning, the edge. So that's going to play a great role. And if you dwell deep, right, I think being open would really help because the connectivity and the various platforms will actually give a chance for everybody to come together and kind of be open and work together. I think that's going to bring us a lot of use cases of 5G. And for the future ahead, because if you look at what we have done so far, right, it's not that we don't have any use cases. If you look at how insurance is done today currently, I don't know how many of you are aware of that use case, where a particular company is offering a service where if there is a mishap or an accident, you just take a video and photo and upload it to their servers. And your claim is actually approved within 1 or 2 hours. So that's a very fantastic new use case, which saves time, which gives you agility, and your work gets done faster. So these kind of things are going to come up very fast. We will get into generative AI, but again, it starts with inference. With inference, we will be training our algos, we will go to generative AIs, and this will actually become better and better. So what I see is 5G is going to bring a lot of use cases, but we need to be ready with the infra. And also, I think we need to focus on closing the divide, where 5G, the easy rollout of FWA gives that opportunity for us.
Okay, great. Thank you, Girish. With that, I would also like to invite another panelist with us, Harpinder. Harpinder is the business head for product and marketing AMD. So, morning, Harpinder. So, with that, if I can move to you, Jayanta, and I think you have been seeing this entire journey for last many years. So, how will 5G drive industrial transformation? And will it serve as a catalyst for driving digital transformation across sectors? So when we talk about the sectoral convergence, we talk about, and I think what I've heard primarily use cases coming in more on the manufacturing, utilities, and another kind of agriculture is another area which is coming in. So how 5G is providing those opportunities, leveraging maybe the industrial IoT, and maybe a private 5G network, which we are talking about. If you can also elaborate a bit what exactly is that, that'll really help. Thank you.
Thanks, Nitin, and good morning to all. So, 5G, particularly private 5G, is a great enabler for the digital transformation that is taking place across the industry verticals. Now, as per industry reports, globally, the 5G adoption is taking place in three main segments. First is manufacturing, second is transportation and logistics, and third is energy and mining. So let me start with manufacturing and in the context of India. So as most of you are aware, due to the current geopolitical scenario, all manufacturing companies globally are looking for diversification of their manufacturing supply chain. And most of the manufacturing companies today globally are essentially adopting a China plus one strategy. So India has the great opportunity to be a manufacturing hub for the whole world. So we are talking to a lot of manufacturing players in the country today, and we see a lot of interest in them to modernize their factories, to transform their factories into smart factories, and to build factories of the future. Now, the foundation building block of industrial IoT or to implement Industry 4.0 use cases is that you have to collect very accurate data in real time and from hundreds and thousands of devices, sensors, and machines in the whole manufacturing plant. So this calls for a network infrastructure that is highly reliable, is highly performant, is highly scalable, and has very low latency. And most of the manufacturing, and in fact all enterprises, also look for high security, which means that the data cannot leave the premises, whether it is a shop floor, a manufacturing plant, right? So if you look at all these stringent requirements of these mission critical applications, 5G is best suited to meet the requirements of these mission critical applications. So let me take a few examples based on the conversations we are having with some of our customers here in the country. So one of the leading automotive OEMs in the country today is looking at how 5G, and when I say 5G, I'm referring specifically to private 5G, how private 5G can help this particular customer of us in improving the monthly production of vehicles. So today, as you know, in automotive vehicles, electronics and software is a significant component of a vehicle. So as a part of the production process, you need to flash the software into the vehicle. And the current network infrastructure that this particular customer of ours have, the software flashing is highly time consuming and is error prone. So this particular automotive OEM is looking at 5G to address this production bottleneck and to be able to increase his monthly production of vehicles. So this is one very good use case where 5G is helping an automotive OEM to increase and deliver additional vehicles per month. The second use case where we are seeing a lot of interest from our customers is how 5G can be used for autonomous mobile robots, for autonomous guided vehicles. Many of you who have visited a manufacturing plant or a shop floor must have seen that it is very dynamic. And for a wireless infrastructure, a manufacturing plant is very challenging because there is a lot of interference, there is a lot of metal objects, very high temperature due to furnaces, welding machines, and other heat generating manufacturing processes. So 5G is being used by these autonomous mobile robots and autonomous guided vehicles to provide reliable services. And more in the shop floor, these AMRs and AGVs are being used to automatically carry raw materials, semi-finished goods, components, and parts. So these are two, use cases we are seeing in the country when we are talking to a lot of our automotive customers and other manufacturing customers. Now, HFCL, we also have our own manufacturing plants. As you know, we manufacture optical fiber and optical fiber cable. So we are also implementing some of the industry 4.0 use cases in our own factory. So one of the use cases we are implementing is real-time dashboarding to help improve production yield. The second use case that we are implementing is how do we improve the quality process through real-time vision-based analytics so that during the production process itself, we are able to inspect and identify defective parts. So as we move along, what we definitely see in manufacturing, we are now moving from an era of mass production to an era of mass customization. So factories of the future will need to make quantum jump in productivity improvement, will have to be highly agile to be able to meet changing market requirements, and will require zero machine downtime. This means that there will be a huge adoption of some of the emerging technologies like digital twins, generative AI, and industrial metaverse. Now, all these technologies that I just referred to cannot be implemented unless you have a highly reliable, highly scalable network, and this can be delivered only by 5G. So I think I spent a bit of time on manufacturing, but 5G and particularly 5G private has equal relevance for other sectors, industrial sectors as well, whether it is mines, ports, right? So one of the challenges that ports and mines have, that their operations are spread over a huge area, sometimes covering, hundreds of acres. Now 5G helps to efficiently cover this wide area and to be able to, easily implement use cases like asset tracking, right? And to embed intelligence into the operations, right? Then when I look at energy and utilities are making use of the reliability of 5G to implement smart grid, to integrate new energy sources, green energy sources like wind farms and solar plants into the energy grid. So we see that 5G will act as an accelerator for the industrial transformation that across all industry segments.
Great. Really insightful, Jantar. Thank you for sharing that. And I think you brought an important point. What I could relate with what Girish you also mentioned, that infrastructure is the key. Depending on the use case, and particularly when you're talking about the private 5G or 5G private infrastructure is the key. The second point I think very interesting, and I'll quote somewhere, mass production to mass customization, which is also something maybe 5G provides an opportunity for. And considering infrastructure is so key, maybe I'll move to you and maybe seek your experience that how should back-end infrastructure, which we just heard is very critical for any kind of a 5G services deployment, this should be progress for effective deployment and operations of 5G, and how we can leverage some of the network slicing capability that 5G provides.
Great. Thanks for the question, Nitin. Thanks to everybody for coming. It's like the worst session of the week, the first session on the last day, so the fact that you've all showed up is great. I'm aware that there's a cricket game going on as well, so it's doubly good that you've all come to this instead. And the final note on that, I'm probably the token Englishman in the room here, so can I just ask everybody to go easy on me later on, please? So I'm going to start off, maybe be a little bit contentious, right? That I'm going to put a premise out there that as technologists, we're really bad at predicting what the killer application is going to be. I think we're really good at innovating, and particularly here you see the pace of innovation. But I think we're really bad at working out what that killer application is. And let me give you an example about that. Go back 30 years from now. It was December in 1992. And the first text message was sent. It was an engineer, a young engineer, sent a text message to their boss saying Happy Christmas, because his boss was at a Christmas party. That was the first use of a text message for non-network information. And SMS in GSM at the time was never really intended as a user application. Now, you fast forward from that, fast forward just 5 years from that, we've gone from something that was never intended to be a user application to having the first mobile payment system, at least I'm aware of, where you could go to a Coca-Cola machine, you could send an SMS to that machine and it would dispense a can of Coke for you. So think of that, 5 years from effectively a new service being established to it then having a entirely new business model. Magnus was talking earlier on about business models. And then you fast forward to where we are today, 20 billion text messages every day. 20 billion of something that was never intended as a user service. So that's what leads me to my premise that we're not very good at predicting that application. We didn't predict that one. But we are very good at adapting to it. And so the key point I want to stress here is the need for programmability and the need for programmability end-to-end across hardware and software. Because if we're not going to be very good at predicting the application, then we need to be able to adapt to it. We need to be able to innovate. We need to have faster feature velocity in order to embrace those new areas. And you see that pace, you see that speed of innovation occurring here, occurring at IMC, the difference from last year to this year, the deployments that are occurring, the private networks models that Jayanta was just talking about as well. It's incredibly exciting, but that's where we need a portfolio of solutions. We need end-to-end programmability, and we can't have a one-size-fits-all approach from the back-end infrastructure point of view. And then we just talk about a couple of examples about where that pace of change is required from a future-proofing point of view. Think for a moment about artificial intelligence and machine learning. So AI and ML is kind of uniquely both enables 5G and is enabled by 5G. If we look about 5G being able to extract data from the edge, about being able to utilize all of that data as well, there's a great opportunity for us there. And then 5G can also benefit from machine learning as well. If you think about, just to throw a few examples out there, you think about L2 scheduling or intelligent RIC, or if you think about there's this classic amplifier digital predistortion problem that's a non-linear problem that we've always approximated to with linear mathematics. Well, now, machine learning is the best way of doing amplifier digital predistortion. So we have all of these ways that 5G can benefit from ML. But if we'd designed that, if we had a fixed hardware implementation that we developed a few years ago, we wouldn't have implemented transformer networks. We would have been inherently implementing something backwards looking rather than something forwards looking. And so that's where I come to my point about needing programmability to have future proofing, to have feature velocity. If you'd have implemented a neural network machine a couple of years ago, and if it was fixed, you wouldn't have been able to do a transformer network, and then you would be limited in what you could do with generative AI, for example. So as we look going forward, we have to make sure that we've got that feature velocity for all of the different applications. I also wanted to stress about where there's some really exciting things from future-proofing and programmability from a usage model perspective as well. So Jayanta just gave some great examples about private network in industrial applications. But I was talking to a number of different delegates here about in transportation, and particularly in the train network. And you think about the train network, what a great example about network slicing that Magnus, to my right, just talked about as well. If you have a network slice, for a train network, I can both have a network slice that supports infotainment in the seat back, but I can also have a different network slice with higher quality of service, that supports ultra-reliable, low-latency we connectivity for safety-critical applications. And again, by that programmability built into the back-end infrastructure and built into the hardware that's provided, we uniquely enable that new kind of application as well. So with that, I just wanted to kind of tie it up at the end and particularly make that point again about the need for programmability. And if anyone disagrees with me about us not being any good at predicting applications, come and talk to me afterwards and I'll definitely invest in your startup idea. Thank you. Back to you, Nitin.
Great. Thank you, Mike. And now I'm really excited because you spoke about need for programmability. You spoke about AI, ML, and obviously slicing, which obviously brings me to my favorite topic, which is on cybersecurity. Because with so many things are happening, cybersecurity certainly becomes critical for this aspect. And this is like my perspective, and Azhar, I'll come to you to seek your opinion around that. What we have been doing on cybersecurity to date, securing the telecom networks, may not work so well when we're talking only for 5G. And it has to cover across the user landscape beyond the management and control landscape. So that's where I think I wanted to seek your opinion and your views. How, obviously it's important to secure 5G services, but what are the key aspects when you talk about evolving risk from cybersecurity perspective, specifically on 5G?
Sure. Thank you, Nitin. And thank you, everybody, for this opportunity. Before I get into the cybersecurity question very quickly, I'd like to double down on a few things I think the panelists made, because they're important to set the context with respect to security. One of the things that was talked about was scale. The other one that was talked about was reliability. The third one that was talked about was different use cases with respect to connectivity. 2 decades ago, we talked about quality of service on an internet service in a different way than we do today, because today we use Zoom. So connectivity is absolutely a necessary but not sufficient requirement to build new services. It's absolutely necessary. High-speed connectivity, build it as they come. I'm sure we all learned that particular paradigm. But what it also does now with high-speed connectivity is the amount of data that you're ingesting. I think you brought that point up earlier. With that kind of data ingestion that happens, and the observability parameters that we've actually put as part of the particular infrastructure, you're generating more and more. Users are generating, sensors are generating, infrastructure is generating data. And now you got to look at that particular data and then run some sort of analytics. The questions naturally come up. What about security? How do I do data management? How do I do privacy? And you look at privacy concerns. You look at user data versus infrastructure data, separation, sovereignty. So these are all questions that immediately come up because now people are already building a lot of data lakes. People are already doing a lot of analytics. Sometimes people really don't care about the GDPR laws in Europe. It's very different, in US very different. India, I think, is just beginning to adopt a privacy policy with respect to data, right? So I think those things become absolutely necessary, especially in the context of infrastructure. Let me parse down a few things from an infrastructure and then go to the user perspective. From an infrastructure perspective, when you have observability and that kind of data, now you need to actually look for what is the posture of that particular infrastructure? How compliant is it with respect to regulation? How are you able to really satisfy all of the requirements? For that, you need to automate it. You need to probably use Gen AI techniques. You need to actually do what is called as hyper-automation, in my opinion, in terms of constantly checking, verifying, and providing information back to human-in-the-loop conversation with respect to automation to ensure that you're actually compliant. You're actually be able to prove yourselves that this actually works. And this is where it needs to be. Now, that is on the infrastructure context, but what about the user data, right? What about the privacy concerns in that particular context? Where, with respect to user data too, you cannot treat user data the same way you did before. I mean, I know that these days we are becoming increasingly more sensitive. Just simple changes with respect to GDPR allowed us to, have a button on the web page every time to say, do you accept cookies or you don't? I think we need to evolve that in many more ways. And that's actually, I'm going to double down on Mike's point here in terms of bringing better programmability. Better programmability ensures, you have the right kind of APIs. GSMA has actually taken up a project in Kamara in terms of how information sharing and user information sharing can happen with respect to this one API context. So I think those need to be further worked on. We need better frameworks around particularly data management and cybersecurity. I think we need to be able, we have to do more. We just can't simply say, yeah, let's do connectivity, let's worry about this right now, and everything else will automatically fall in place. Yes, maybe, but the pace at which we're changing, it's really, I mean, in India, you have a fantastic application, something called DigiLocker. I just learned about that, in this trip. It's an awesome piece of application. The big part is not just the application that stores your creds or credentials, but whatever it is, whether it's your passport or your driver's license or something else, but it's universally accepted by the government and the enterprise as something that's secure, right? We don't have such a thing back home, where I live at least. I can scan it, I can put it on my phone, but that's not acceptable as an authentic verified document. I think these are some really innovative things that people have done here because of the digital inclusion, because of the connectivity, because of high-speed connectivity, and 5G will further improve and enhance that, and it is secure. So I think it can be done. India has shown that it can be done, and I'm sure we can actually extrapolate that and apply that in the enterprise context, in both in B2B and in B2C context.
Sure. Thank you, Ajay. And I think you did mention about the data part, data monetization part, and also securing that, particularly when it comes to the personal information. So for that, if I can just turn towards you, Dr. Badri, and seek your views in terms of what are the role that a regulator should be playing in terms of having an effective adoption of secured 5G services, and also some of the regulations like we spoke about data privacy will gonna have an impact both from positive as well as negative from the adoption perspective of 5G services. So your views on that?
Yeah. Again, yeah. Hello. Yeah. So, from a just following, what the other speakers, we have actually created a lot of expectation on the success of what 5G means to us and so on and so on. I just want to take a step back and, when we talk about security and infrastructure, clearly we have built it on the backbone of a fiber optic network, and that continues to be the driving, let's say, enabler to get more and more towers built out, more backhaul networks built out, and then as we grow these services and these applications, whether it's in manufacturing or private 5G or things like the inclusion, which is, by the way, a fantastic application. I used it at a police check a few weeks ago to show my ID. It is amazing, these services. But I just want to make a small point that the way at least we have built that fiber infrastructure has always been vulnerable to damage, right? For example, there is, if you look at the statistics, here in India at least, the number of cuts per month per every 1,000 kilometers of cable assets that are in the ground or in the air, it's about 15 cuts per month. Whereas in other geographies, especially out west or maybe Japan, it's in the sub 1, it's in the 0.2 to 0.3. So we're quite, we don't have a shining example of physical network security on which we build this 5G in the future, right? Now, the point I'm trying to make is, if you look at recent events, Middle East, in places like that, Ukraine, it is very easy to disrupt that infrastructure. You don't need very sophisticated warfare or fighter jets and this and that to disable it. So one thing I would kind of ask from a regulatory standpoint is best practices in securing the fiber network so that you bring your outages down to zero. It is absolutely a mandate, I think. It can be done. It is a matter of unifying certain allocations of licenses, rights of way, enforcing the dig first, call first, call before you dig, these kinds of things. These are simple things to do on paper, but it does require a behavioral transformation, a business transformation for us to understand that this is something, if not done today, it could in the next 5, 10, I don't know, God forbid there is some kind of an event, you know, but that is, let's say, a more, a high risk, scenario. But even today, the number of outages that one goes through, whether it's your private broadband at home, on which your 5G tower depends, or your, data center connections, or even the physical attenuation that we experience in the network, right? If you speak to data center, operators, everybody is concerned about the quality and health of this network, right? So that is something regulators should look at, I think, for the first point, right? And to your second point on the the information security itself, I don't have much more to add than what people have spoken about. I mean, that's absolutely important for us, but there is a way forward. There is a path for open source. There's a path for programmability. There's a path for building, higher capacity, transmission equipment that can be, put together in so on and so forth. One way that, and we are working with some operators on this to improve the physical security of the network is, by the way, using AI. In a roundabout way, it is something you can sense when somebody is about to dig before they dig, and that is some property of optical fiber called fiber optic sensing, and that is something that our fiber monitoring. These kind of AI use cases show up in a roundabout way because we started investing very heavily into 4G and 5G and machine learning and AI, and then now we're coming back to it full circle and say, okay, look, we do need to, even if we can secure the network, we need to monitor it, and we need to turn the repair time, mean time to repair, to nearly zero, so that these services are useful in terms of monetizing the use cases. If a network is out for 4 or 5 hours a day, I think in the long run, you'll lose money, right? It's not that complicated. These are the 2 points I would say from a regulatory standpoint to think about.
Sure. Thank you, Dr. Badri. I think on that one, there's an interesting thing which I observed. So I think, Mike, you mentioned a point on one size doesn't fit all. And when you talk about the 5G services and specifically on security, I can just take a clue from Azhar, you and Dr. Badri. I think, as I said, one size will not fit all when we talk about 5G network security as well. So I think when we were talking about 2G to 3G and to 4G, there was a baseline security framework which used to work to secure any communication network. But 5G security specifically needs to be aligned with the use case. I've been reading that there is a concept of connected hospitals which is coming in. Now, you just cannot afford the number of outages that you're talking about. You just can't afford those many outages when you're talking about the connected hospital and remote surgeries and all those kind of use cases. And specifically, the personal health information becomes another critical aspect when you talk about those. So, depending on the kind of use cases, I think that's where you have to balance. And obviously, automation is another fundamental key when you talk about cybersecurity in such of the emerging areas. So thank you very much for bringing that up. And with that, before I come to the audience, obviously, I want to come to you, Harpinder. So I think after all those discussions, what are the 3 initiatives that you want to propose to drive industry collaboration for driving an effective utilization of 5G capabilities to bring socio-economic growth for the country?
Thanks, Nathan. So you're asking for 3 key initiatives that can...
if you have more, I'm more than happy to have more.
Okay. So, first of all, given that I'm from AMD and we provide technology for end-to-end 5G as well as data centers plus GPU clusters for AI/ML. So I'm going to provide a perspective on socio-economic growth with a different lens, right?
Sure.
You called out 3 initiatives, right? So I would say these are not new initiatives, but I'll just reiterate some of the initiatives that we have just started, or these initiatives are in baby steps, I would say, right? The first one we talked a lot, as we marched into 5G was hardware and software disaggregation, and all of you know about Open RAN Organization Alliance, right? So there was an intent to kind of create an ecosystem where radio from any vendor can interoperate with base station or baseband from any other vendor, right? From tier 1 OEMs in particular, right? So from that perspective, a lot of the technology providers enable the ecosystem, and today we have a thriving ecosystem that can provide radio. Essentially, when you talk of socioeconomic growth, it's very important for us to have a thriving supplier base as well. So today we have, say for example, if you go through the show floor, you find that there's a radio hanging from pretty much every booth, and if you come to AMD booth, you'll see that there's a wall which is full of radios that are made in India, right, from that perspective. Now, the key thing is that now we have radio suppliers, and this is one of the challenge every tier 1 OEM has been facing, that they have to build one new radio every week, and they simply cannot keep up, right? And we're just talking of FR1, when you bring it FR2, and then as we go into 6G, FR3 bands are being considered, right? And then you have terahertz. So you have so many different SKUs of radios that you need to support. So you need to have a very thriving ecosystem to support all those use cases. Now the problem there is that these radios today cannot interoperate very easily, right? So they're struggling to really get these radios deployed because there is a gap in terms of availability of DU that they can have access to or they can interoperate with. And if they get one, the performance is still deficient compared to something that is built by a single vendor, both baseband and radio. So I would say that there is room to make progress there. We have made some steps there in that direction. I think we have to continue to build on that and create an ecosystem that allows greater inclusivity, greater participation from the industry base to contribute radios for different use cases, for different verticals. We talked about private 5G. There's a different scenario where maybe operators cannot directly participate right away. They have different priorities to begin with, right? So that is number one. Then talking of number two is, again, it's very familiar to us. We've been talking about software and hardware disaggregation, and oftentimes we talk of vRAN, right? So, and this also was quite a big hype as we started on 5G journey. And so vRAN has happened, maybe I would say 5% deployments are using vRAN, but it's not truly vRAN in the sense that it's still proprietary because it's fixed to a specific hardware, or the software stack that is coming is again coming from either tier 1 OEMs or provided by a vendor, but then it's not quite open, right? So in order to really enable broader ecosystem to be more inclusive, to enable multiple vertical industries to participate, we have to provide this baseband framework that enables each vertical industry to participate more with more ease, right? If you talk about massive MIMO baseband, it's still. I was talking with one of the operators, and he says that truly it still is a rocket science because it's so difficult to really optimize that system. So not everybody can really come up with a solution that is end-to-end. So from that perspective, I would say that there is still room for us to make progress on hardware and software disaggregation to enable a framework that allows the baseband software to be open source, to be available as a Linux release, along with providing APIs so that even tier 1 OEMs can leverage the same software framework to create similar differentiation that they do with their purpose-built boxes, right? At the same time, we have now smaller, innovative companies. They have specific problems to solve for their vertical, or for urban or rural, for agriculture, or any other application. So they can come in and can leverage some of these frameworks that are available to add on their own APIs and solve their problems, right, using the same framework. So I think we need to make progress in this domain. Otherwise, I don't think so 6G will happen without that, because 6G is very much dependent on the third component, which is AI/ML, right? So because we called 5G to be cloud native, and now we are calling 6G to be AI/ML native. And I'll come to that in a minute. But the key thing is that if we have to enable 6G, we have to really have an open open equipment approach in the sense that you need to get access to the data sets. If you don't have access to the data sets, okay, you can still use reinforced learning-based AIML algorithms to really do something, but without having access to the data sets, it's going to be very difficult for you to tap into AIML from utilizing it within the infrastructure or managing the infrastructure, and then subsequently also leveraging this data set for creating new services, right? So I would say that AIML, why we need to pay attention to that, first thing is that there's significant amount of energy being spent in this area. Like you see new folks coming out of colleges, or the amount of research that is happening in AIML is quite significant across the board. So we have to tap into that. But if you step back and look at AIML, how it's done, basically any signal processing expert will see that essentially AIML is leveraging matrix manipulations, which is very much core to signal processing algorithms that we use in baseband, particularly in layer 1, right? So from that perspective, we see that there are some use cases like Mike also mentioned about that. Say, channel estimation is one very important area where significant improvement can be made. We certainly will continue to evolve the traditional algorithms as well, but we have to look at some alternatives that can provide good balance between system complexity and performance. And then, of course, scheduler, you mentioned about that, right? So these are the areas, where we have to enable these areas by, say, having open baseband implementation, which has got standardized APIs, either 3GPP or Open RAN Alliance creates this framework so that folks who are having expertise in this domain can come in and can provide improved channel estimation or equalization model that can be leveraged by any other vendor. And likewise for scheduler, because today if you have a deployment, you'll see that if the spectral utilization, even though theoretically is kind of spec to be, say, 100%, in reality, you'll be realizing only 1/5 or maybe 1/4 of the spectral utilization in a practical deployment. So there is significant room for us to make improvements there as well. So I would say that these are the three key areas. If we enable and have a rich ecosystem, thriving ecosystem, then certainly it can intercept multiple verticals, multiple areas to really bring in with the connectivity with 5G as well as growing it to the next step, which is 6G.
Great, great. Quite a detailed, elaborated perspective, Harpinder. Thank you very much for sharing that. So with that, I have one question for all of you, but before I go to that, maybe I'll just turn to the audience and see if you have any questions for our panelists. We'll be happy to take that up now. Yeah, please, sir, go ahead.
Thank you for your great knowledge that you shared the success of 5G deployment. My name is Dr. Lawal Bello from Nigerian Communications Commission, NCC, a body saddled to regulate the telecom sector in the country. There are some factors to consider in deploying 5G globally. Some key factors. One, the OEMs. Two, the telecoms regulatory body. The OEMs, we can consider them as a kind of key drivers in deployment of 5G. Now, one of the big challenges of 5G deployment nowadays is high cost of deploying the services. What OEMs are doing in terms of equipment subsidy, incentives to ensure that the telecoms operators access the equipment at a low cost so that the services will be more affordable to consumers. Because globally, if you look at from the time of launching of 5G to date, the subscription by 2023, end of 2023, will reach like 1.5 billion. And most of the subscribers are enterprise solutions. Therefore, what kind of subsidy OEMs or kind of incentives are they providing to telecoms operators to ensure that the services will be affordable to consumers? Thank you.
You want me to go first? I think very valid question that the new technology that we bring in should reach everybody and at a cost where everybody can afford and use it. So from a transport perspective, I think what you will see OEMs doing, and it's not only related to CNR, you'll see a lot of convergence. And that's going to be the norm where every OEM will come and tell you that this is where we'll reduce the cost of deploying the network. You must have already seen a lot of photonics, low-cost photonics, performance optimized photonics, performance space optimized photonics, and also the pluggables. So this is going to be the new era where you will find OEMs working together with SPs, delivering those low-cost solutions to create a lot of capacity much, much closer to the user. And this is something that we are also doing with our partners. The other thing, convergence. Of late or till now, you've seen multiple networks being built. That's also going to change. You'll find a single multi-layer network that can cater to all kinds of services. So that's going to be the next norm, which promises to reduce the cost almost by 40%. And it'll be a sustained model where you can actually select and choose what you want and what needs to be deployed. So these are the two things that transport OEMs will promise and deliver on putting low-cost networks.
Okay, so your question, if I paraphrase it quickly, is how can the mobile services be more affordable to consumers? And I think the challenge is great, and that's an ongoing race all the time. But I think if you look on both the infrastructure side, on the mobile device side, when we go into 5G, we do absolutely the best technology we can do in the industry. And we do so because we know that at scale we can deliver the lowest cost per bit. Can show here, it's a ASIC. It's a dedicated chipset that Ericsson has made. We have it in our antennas. It's 9 billion gates, dedicated for its purpose of delivering a better service. That is a cutting edge what the industry can do in the world. Now, as an example, I think, look here in India, where 5G is launched now, and we're operating at ARPU levels of $2.50. It's just phenomenal. The race now is to drive the scale, so cost of devices goes down, and it will over some years. We've seen a good trend already from the start of 5G, and give it another few years, it will drop. And it will be the lowest production cost ever in the industry. Then we continue based on that, and we take the next technology step and continue that race year after year.
Yeah. Other.
If I could just jump in very quickly and just echo that point. There's a relentless march on from a semiconductor point of view. My colleague on my side over here, from an AMD point of view, at Intel, we're driving it through Intel Foundry, through TSMC, through Samsung, going from lower and lower process nodes to support Magnus's ASIC that goes in their radio unit, and increasing the number of transistors that go in each time, which obviously can drive capacity, but is also driving down cost as the kind of key part of that. And the other reason I wanted to jump in as well is a huge part of that is also driving sustainability as well. As we go to the next process node, we've gone from measuring things in nanometers from a gate width to now at least in Intel, we measure them in angstroms now. That's how fine a pitch we're doing. As we do that, we're driving down the power consumption, and that's the other area that we need to do. Not only we need to make it affordable, but we need to make it sustainable as well. Thank you.
Other, yeah.
Let me just take a step back to your question. You want to drive down costs for a new generation technology that's coming. At a very high level, that's the question. How can you do that, and what are the OEMs doing? That was the original question. What are some of the levers of driving down costs from a consumer point of view, from a provider point of view? Some of the levers that drive down costs are architectures. What type of architectures do you choose? Are they closed or open? How do you allow competition to actually drive some of that cost down? And how do you create value within that particular framework? So if you take those levers, start pulling those levers. You have the power. As a provider, you have the power. You cannot you cannot just be captive to a vendor's approach in that particular context. Above all, in this context, of course, go towards COTS hardware. Don't go towards dedicated hardware. If you can, do it. Of course, you have to worry about what he just said, is just driving cost per bit down, right? Can you pack more density into that particular piece of hardware and actually drive cost per bit down? Look at that, right? Go to adopt open source technologies, create an ecosystem of environments with smaller, startups, companies, work with them. They're more hungry for business. So look at that. And as a matter of policy, you're actually, I heard that you're part of some, defining policy. As a matter of policy, define what you need in that particular context by providing that kind of, those level of investments. Open source is a gigantic lever, don't ignore it. Of course, above all, and all this, adopt cloud. Those are some direct answers you're getting from me.
I just wanted to add one point.
Yeah,
in
please.
addition to the technology innovation that everybody referred to, the other is also, to make services affordable are the business innovations, right? So for example, shared infrastructure, not only the passive infrastructure, also the active infrastructure, can it be shared? That will drive down costs, right? Secondly, neutral host, right, is again another way to ensure that we bring down costs, right? So both technology innovation as well as business innovation is needed.
Absolutely. Great, thank you. Do we have, I think we can take one more question, if we have any. Great, so with that, thank you very much. I think we had a very fantastic discussion. I have my learnings to say that, yeah, this is a great promise and quite a real promise that 5G is making. But one of the key things which I've learned today is that it requires a behavioral change for a successful consumption of 5G services, both as a consumer, as enterprises, and obviously as OEMs, to ensure that the cost is optimized as we move ahead. It also bringing us to the shared economy. So a lot of those business models and the operating models that we're talking about will get further enhanced with 5G if we obviously are looking at the shared economy. So there's a lot to go, but I think this is a lot which is happening and which has happened. So with that, we stay positive, and I think 5G will bring us to the promise that it makes. So thank you very much. Thank you very much for joining us, and thank you all. Thank you.